Okay, so this is an example of a momentum question where there is a total momentum of 0, okay, which seems a bit strange. So you've got a bullet of mass 4 grams. It's fired from a rifle of mass 2.0 kilograms with a muzzle velocity of 380 meters per second. And they want to know what the initial recoil velocity of the rifle is going to be. So if we look at the before case, and remember with momentum questions, you always draw a picture before and after. The bullet is in here. So the gun and the bullet are essentially one system together, okay? So you've got your 2 kilogram mass plus the 0.004 kilograms, which is 4 grams, bullet in there. So total momentum before, obviously that's its mass, but its velocity before, the initial velocity here of the system here is 0. And as a result, the momentum before, even when you plug in those numbers, you get your 2 kilos plus your 0.004 kilograms there, but you're multiplying that by 0 velocity. And of course, when something has got a 0 velocity, that means its momentum is 0. Okay? So the momentum on the left-hand side is completely 0. But obviously the momentum on the right-hand side of the individual parts is not going to be 0. But by and large, but regardless of whether the individual parts have momenta afterwards, the sum of the momentum before and after have to still be the same. So after you fire the bullet is going to leave the gun with a velocity of 380 meters per second. And if you notice, the velocity of the gun is going to go in the opposite direction. If you've ever fired a gun, you'll notice the bullet goes forward and there's an automatic kick back, what they call the kick or the recoil from the gun, okay? And that's the velocity of the gun moving backwards. So if I plug in the numbers here, then I've got the momentum afterwards is going to be the total momentum of the gun, which is made up of the momentum of the gun here plus the momentum of the bullet. Okay? Sorry, that should have been the total momentum of the gun and the bullet. So that's 2 kilograms times the velocity of the gun. I'm not going to put in the negative v there. The negative v is just going to come out through the calculation. And we've got the mass of the bullet, and I've got the muzzle velocity of the bullet as well. Okay. Now, if I work out what that value there is, that turns out to be 1.52 kilogram meters per second. And once again, just like we've done before in those examples, I'm going to represent that as a vector. Okay? And that vector, I will say, is going to the right with 1.52 kilogram meters per second. Now, if we know that conservation of momentum still has to apply, that means that the total momentum afterwards must also be the same as it was before. And initially, the momentum before was 0. So that means that the momentum of the gun must point in the opposite direction to the momentum of the bullet. And it must also have a magnitude of 1.52 kilogram meters per second. But of course, it's going to be in the negative direction. Now that will come out through the calculation, okay? So the momentum of the gun is 2 kilograms times the velocity of the gun, and that's going to be equal to negative 1.52 kilogram meters per second. Okay, that's just subtracting that from both sides. The 0 stays where it is. Now all I have to do is divide in order to find the velocity of the gun. So I divide both sides by 2, and that's 1.52 divided by 2 kilograms. The kilograms cancel, and I wind up with 0.76 meters per second. Now notice the negative sign comes with that, okay? And that is because the gun is moving backwards at a speed of 0.76 meters per second. Okay, so just to walk through that one more time, because I do know that this is a confusing topic. Initially, the momentum here was 0, so I can't draw any vector. Momentum here is 0. total momentum is 0 before. If the total momentum is 0 before, that means that the total momentum afterwards also must be 0. Momentum is a vector. The two individual parts of the system, which were together before, are now separated, but and each one of them has its own individual momentum. The momentum of the bullet has got a positive value of 1.52 kilogram meters per second, and that means then that the momentum of the gun must also have the same value, but in the opposite direction. Okay? And from there, you can solve for the final velocity of the gun. And that turns out to be 0.76 meters per second. That is its recoil velocity. Its recoil speed would be simply 0.76. Hope that makes sense.